Hello and welcome all of you to the fluid mechanics class. Today we will solve the previous year questions of fluid kinematics. We will also discuss the concept to deal with all those questions. So let's start the class, and here is the first question on your screen. In the question, the velocity component along x and y directions are given as u and v respectively. Now, for this velocity field, we have to write the convective acceleration along the x direction. So, for understanding this convective acceleration, first of all, let's understand the acceleration equation, which is here on your screen. Here the acceleration is defined as, in the flow field, acceleration is defined by this equation. A is equal to del v by del t plus u del v by del x plus v del v by del y plus w del v by del z. This v is the velocity field and is a function of x, y and z. And this u, v and w are the velocity component of the in the x, y and z directions respectively. So, the acceleration in x direction can be written in this form. Similarly, ay and az is written as in these forms. Now, this equation can also be written in the vector form. So, here you can see there are few terms in this equations. So, the first term, this del v by del t, this is the del v by del t. From the expression here it can be seen that this is the time rate of change of velocity, and this term is independent of space coordinate. So, this term is only changed with the time and it is called the local or temporal acceleration. Here it is written local or temporal acceleration. So, the first term del v by del t is called local or temporal acceleration. Now, this remaining three terms is the function of space coordinate x, y and z and are called convective acceleration. It is all this last three terms is independent of time and is a function of space coordinate only and is called convective acceleration. So, here in the question it is asking about the convective acceleration along the x direction. So, we will use this equation Ax. Now, since this is asking for only two dimensional, so we will use only these two terms u del u by del x plus v del u by del y. Why? Because this term is called local acceleration and last three term is called convective acceleration. So, we will use the last three terms, but here it is asking about only two dimensional. It means we will use only x and y axis. So, here the correct answer will be option number A. So, the convective acceleration will be u del u by del x plus v del u by del y. Here just read the question. In this question there are three flow field is given P, Q and R. This P, Q and R is given. Now, we have to check which velocity field is incompressible or irrotational. So, for checking the incompressibility and irrotationally, there are few equations which we use. So, those equations are this equation of continuity and this equation. So, equation of continuity is this one. The first equation is called equation of continuity, del rho by del t plus del x of rho u plus del y of rho v plus del z of rho w into dv is equal to 0. This continuity equation can also be written in the form of vector form. So, here this first equation can be used for any types of fluid flow. whether it will be steady flow, unsteady flow, uniform, non-uniform, rotational, incompressible, irrotational. Okay, we can use this equation for any possible case of flow. So for steady flow, what happen? Steady flow, we know the in the steady flow, the flow property does not change with time. Flow properties that does not change with time, that is, it is constant with respect to time. So in case of a steady flow, this term will be 0, this term will be 0. So the equation of continuity for steady flow will become this one only. And for incompressible flow, what happened? For incompressible flow, the rho is constant, density is constant throughout the liquid, throughout the fluid. So we can write, since this rho is constant, so the derivative of constant will be 0. This will be 0 for compressible flow, and these terms will be constant, so it will come outside, and the equation of continuity becomes only this one. So this equation is for compressible fluid, incompressible, for incompressible fluid. Okay. For incompressible flow, we can the continuity equation becomes this del u by del x plus del v by del y plus del w by del z. By showing this equation, we cannot comment on the steadiness of the flow. It may be steady, it may be unsteady. Okay. So by writing this equation, we can only say the flow is incompressible. If we write in this equation in the vector form, we can write in this form only, equal to 0, and this is for incompressible flow. It may be steady, it may be unsteady. We cannot comment on the steadiness of the flow. Okay. So here, to check the incompressibility, we will use this equation. Now for irrotational flow, the angular velocity becomes 0. For xy plane, the angular velocity with respect to z axis will be 0, and the equation of angular velocity is this, half of del v by del x minus del u by del phi. So now we will check for p, q, r, we will use both the equation and we will check the incompressibility and irrotational. So for p, del u by del x is what? Del u by del x is 0 plus del v by del y. Del v by del y is what here? 0. It is also 0. So it is 0. So we can say this flow field is incompressible. Now for irrotationality, we will use this equation. So here the omega z, half of del v by del x. Del v by del x is minus 3 minus del u by del y is 2. So it becomes minus 5 by 2, which is not equal to 0. So this flow field will be not irrotational. That it means it is a rotational flow. So p is cancelled because it is incompressible but rotational. So p is cancelled out. Now check for u. Here del u by del x is what? Del u by del x is 3y and del v by del y is what? 0. So it becomes 3y. So it means it is not an incompressible flow, means it is an compressible flow. So it is also cancelled. Now check for r. Here del u by del x. Del u by del x is what? Del u by del x is minus 2 plus del v by del y is plus 2. So it is 0. So we can say this is incompressible flow. Okay. Now check for irrotationality. The formula is this one here. So omega z here check, half of del v by del x. Here del v by del x is what? 0 minus del u by del y. Del u of del y is what? Again 0. So it comes 0. So here in both the terms this equation is satisfying. It means it is incompressible and irrotational flow both. Okay. So this r velocity field is incompressible as well as irrotational. So the correct answer will be option number D, that is R. Here a two-dimensional flow field has velocity along the x and y directions are given. So what will be the equation of a streamline? So a streamlines, this definition, a streamline is what? The line of constant stream function is called a streamline. Now what is a stream function? So the stream function is defined as a scalar function of a space and time such that its partial derivative with respect to any direction gives the velocity component at right angle in the counterclockwise to this direction. Okay, and just suppose this is x axis and this is y axis. Along x axis the velocity is u, along y axis the velocity is v. So from the definition of a stream function, it is saying that the derivative of psi means derivative of a stream function with respect to any direction. Suppose it for x, okay, del psi by del x will give you the velocity component at right angle to the anti-clockwise direction. So here in the anti-clockwise direction and at right angle the velocity component is v. So it is giving v. Similarly for y, del psi by del y. Del psi by del y will give you what? 90 degree anti-clockwise velocity component, which is what? Minus u. In negative direction, it is minus u. So what is the definition? Definition of a stream function is derivative, partial derivative with respect to any direction gives the velocity component at right angle. Okay, only these are the, this is the basic definition of a stream function. And since this stream function is a function of x and y, so by applying chain rule we can write this d psi equal to del psi by del x into dx plus del psi by del y into dy, where del psi by del x is what? Del psi by del x is v dx, and this del psi by del y is what? Minus u into dy. Okay. Now what is the streamline? A streamline is the line of constant stream function. So for constant stream function we can write d psi equal to 0. It means this function will be 0, which is written here, v dx minus u dy equal to 0, and this will become this dy by dx equal to v by u, or we can write in this form also. So this both the term we can see the equation of a streamline. Okay, where this dy by dx is called the slope of the streamline. So here it is asking about the equation of a streamline. So write the equation of a streamline is what? Dx by u. Here u is what? X square t. X square t is equal to du by v, where v is what? Minus 2x by t. Minus 2x by t. So here t will be cancelled out. X is also cancelled. So we can write dx by x is equal to minus dy by 2. So on integrating, if we integrate this equation, we will get log x ln x equal to minus 1 by 2 ln y plus constant. So here this, if we just it can be written as 2 ln x is equal to minus ln y plus 2 ln c. However, this is also a constant. So this can be written as, this equation can be written as ln x square. If we just it will come in this side, it will become positive, plus ln y is equal to ln another constant. So it will be ln x square y is equal to constant. So we can write x square y is equal to a constant, and this will become a equation of a streamline. So option number A, here it can be seen x square y equal to constant. So option number A is the correct answer. Here a streamline, path line and a straight lines are virtually identical for which type of flow? So we have read this, the definition of a streamline, path line and straight lines. If you don't remember these definitions and concept, just go through this slide, go through all this definition, you will get the concept of a streamline, path line and straight line. And all these three lines are identical for steady flow, as it is written here. They differ only when the flow changes with time. It means when the flow is not steady. So all these three terms, streamline, straight line and path lines, are identical for steady flow. In case of steady flow, all these lines are identical, virtually identical. So we can see here option number C is the right answer. Here the velocity component in the x and y direction of a two-dimensional potential flow are u and v respectively. So the equation of continuity is what? Du by dx plus dv by dy is equal to 0 for potential flow. So we can write du by dx is what? Minus dv by dy, simple. So here du by dx is what? Minus dv by dy. Option number D is the right answer. In case of steady and incompressible flow, the equation becomes this one for two-dimensional flow. So option number D is the right answer. Here the velocity component in the x and y directions are given. What will be the value of lambda for a possible flow field involving an incompressible fluid? So for incompressible fluid, we already discussed what is the equation of continuity. Du by dx plus dv by dy is equal to 0 for two-dimensional flow. Here it is asking about two-dimensional flow. So here u is this. Okay, so du by dx is what? Here you can see du by dx is what? Lambda y cube. Lambda y cube minus x square y, derivative of this x square y is what? 2xy, 2xy plus del v by del y. Here del v by del y, derivative of this dv by dy is what? 2xy, 2xy minus here 3 by 4 into 4y cube is equal to 0. So here 4 and 4 cancelled and this term is cancelled. So we can write here lambda y cube minus 3y cube is equal to 0. Here y cube is common, lambda minus 3 is equal to 0. So lambda minus 3 is equal to 0, it means lambda is equal to 3. So for possible flow field involving an incompressible fluid, the lambda will be 3 for this expression. So the answer will be what? 3. Option number D is the right answer. You can see this equation which we use for incompressible fluid, the equation of continuity. The next question, if v is a velocity vector of fluid, then just in the previous slide we have read this one, that is for continuity equation, and this continuity equation is for which type of flow? For incompressible flow. For incompressible flow. But from this equation we cannot comment on the steadiness of the flow. It may be steady or it may be unsteady flow, but this equation will satisfy for incompressible flow. So our answer will be here with steady and incompressible flow. No, it may be true for steady and incompressible flow, but it is not necessary that the fluid must be a steady flow. Here steady and irrotational flow, so answer is not correct. Inviscid flow means ideal flow, irrespective of steadiness. No. Incompressible flow irrespective of steadiness. So it is the right answer. Option number D is the right answer for this question. Here we have written this in a vector form. This is written. So for incompressible, what is happened? This rho is constant, so this term will be 0, and it is constant, so it will come outside. So it will become only curl of velocity field equal to 0, which is this one here written. Okay, so it is only valid for incompressible flow, irrespective of steadiness. It may be steady, it may be unsteady flow. So option number D is the right answer for this question. The next question is existence of velocity field is when in the, this is the, first of all understand this velocity potential. What is this velocity potential? The velocity potential is defined as a scalar function of a space and time such that its negative derivative with respect to any direction gives the fluid velocity in that direction only. It means if this is velocity potential phi, so its negative derivative with respect to any direction means negative derivative del phi by del x in any direction gives the fluid velocity in that direction. So, what is the velocity in x direction? U, which is written here. Similarly, for y direction this equation and for z direction this equation. Here this velocity potential is defined in 3 dimensions, but the stream function is defined only for 2 dimensions. Okay, this psi is defined only for 2 dimensions, whereas this phi is defined in 3 dimensions. Okay, these are the difference between this psi and phi. So here we can see if this is the equation of continuity, okay, for compressible flow. If we replace this u with this phi function, so it will become this one, okay, and it will become finally this, and this equation is known as Laplace equation. Okay, so this is the Laplace equation. And if we write the rotational components, okay, angular velocity. So angular velocity, the formula was this one, half of del v by del x minus del u by del y. This is the formula for angular velocity. Okay. Now just replace this v and u with psi, this phi function. So we can write half of del x of v. V is what? Minus del phi by del y. Okay. Similarly, u is minus del phi by del x. So we will get this equation. If phi is a continuous function, then we can say this and this term is identical. So this omega z will be 0. This omega z will be 0. So here we can see, so from this concept we can see this, if velocity potential exists, then the flow will be irrotational because of this omega z is coming 0 irrespective of value of phi. For any value of phi, this omega z will be 0. Okay, so we can see if velocity potential exists, the flow should be irrotational, and if velocity potential satisfies the Laplace equation, this Laplace equation, okay, this is the Laplace equation, it represents the possible steady incompressible irrotational flow. Okay, so by only existence of phi we can say the fluid is irrotational, but if phi satisfies this Laplace equation, we can see fluid is steady incompressible and irrotational flow. So here it is asking about the existence of velocity potential, means fluid is irrotational. So option number B is the right answer. Here the 2D flow with velocity u is given. Okay, u is given. Now we will check the compressibility and irrotationality. So for compressibility we will use this equation of continuity, du by dx plus dv by dy. So u is what? This u is what? U is the velocity along x direction. So here we can see along x direction is this one. So du of d, if we this derivative of this is what? This will be 0, this will be again 0, and this will be only 1. So it will be 1 plus dv by dy, and v is what? The velocity component along the y direction, that is z. Okay. So dv by dy is what? 4 will be 0 and minus y, derivative of minus y is what? Minus 1. So it is coming 0. So we can say, since this velocity field is satisfying this continuity equation of, so it will be incompressible flow. Okay, so it will be incompressible. So either it is incompressible. Okay, now check for irrotationality. So for irrotationality we will use the angular velocity equation, half of dv by dx minus du by dy. So here dv by dx, this dv by dx is what? Here v, this v. So dv by dx, here you cannot see any x component here. So dv by dx equal to 0 minus du by dy. Here du by dy is what? Here it is 2, so it will go 2. So it is coming minus 1. So it is not equal to 0. So this fluid is not a irrotational flow. It means this fluid is a rotational flow. It is a rotational flow. Why it is a rotational? Because omega z is not equal to 0. So here the flow is incompressible and not irrotational. Option number D is the correct answer. Now the convective accretion of the fluid in x direction is given by. Already discussed what is the convective accretion. The last 3 term of accretion, which is here it is written in, it is asking in x direction. Okay, so the term this always be u. So the correct answer will be this one. Okay, option number D. Okay, u del u by del x plus v del u by del y plus w del u by del z. You can see the equation of this acceleration field. This was the acceleration field. Okay, for x direction the equation becomes this, and this term is what? This term is the local or temporal acceleration, and the remaining 3 terms is called convective acceleration. So option number D is the right answer. Now for a steady 2-dimensional flow, the scalar component of the velocity field is given, that is u, v and w is given. What are the components of accelerations? Okay, so first of all find the acceleration in x direction. Ax is what? Formula is remember already. These are the formula. Okay, these are the formula. So ax, here ax is what? Del u by del t. It is asking about the here you can see for a steady component, for a steady flow, what will happen? This del u by del t will be 0. Why? Because in case of a steady flow, the flow property does not change with time. Okay, so this all these 3 terms will be 0. Now for here you can just write ax equal to u. What is u? Minus 2x into del u by del x. Del u by del x is what? Here it will be minus 2 again, minus 2 plus v is what? 2y into del u by del y. Del u by del y is what? Here 0. Okay, and since it is 2-dimensional component, so this term will also be 0. Okay, and you can see here w equal to 0. So this becomes ax is equal to what? Minus 2x into minus 2. It means it is 4x. Okay, now ay is equal to what? Ay is equal to u into del v by del x. So u here minus 2x into del v by del x. V component is this, del v by del x is what? Here is 0 plus v, here v is what? 2y into del v by del y. Del v by del y is what? Here del v by del y is 2. So here it is coming 4y. So ax is equal to 4x and ay equal to 4y. Since it is a 2-dimensional flow, so obviously az is not the concern. So ax equal to 4x and ay equal to 4y. So option number D is the right answer. The next question is, a steady incompressible flow is given by this, u and v is given. What is the convective acceleration along the x directions? Okay, so the convective acceleration, So already we know what is the convective acceleration term, last three terms here, because in case of this is the convective acceleration and this term is called local acceleration. Okay, but it is asking about the convective acceleration along the x direction. It means we will use this equation. So x is equal to u. Here u is what? 2x square y, 2x square plus y square into du by dx. So here du by dx is what? 4x into 4x plus v. V is what? Minus 4xy, minus 4xy into del u by del y, del u by del y. Here del u by del y is what? This will become 0 and it will become 2y only, 2y. Okay. So this is the equation for acceleration in x direction. Now it is asking for point 1 and 2. It means x equal to 1 and y equal to 2. So here put x equal to 2 into x means 1 square plus y square means 2 square into 4x means into 4 into 1. Now this is minus 4 into xy, x is 1 and y is 2 into 2 into y is what? 2. So just calculate this and solve this. You will get the answer is this 2 plus 2, 2 square means 4, 4 plus 2 means 6, 6 into 4 means 6 into 4 is what? 24 minus 4 into 2, 2 into 2 into 2 means 8 into 4, that is 32. So it will become minus 8 unit. Okay, so here you can see minus 80 unit is the answer. Right answer, option number C. Option number C is the correct answer. Here the area of a 2 meter long tapered duct decreases as A is equal to A. Okay, so here a 2 meter long tapered duct is given and this area is given by this equation, where x is the distance in meter. At a given instant, a discharge of 0.5 meter cube per second is flowing in the duct and is found to increase at a rate of 0.2 meter cube per second square. The local acceleration at x equal to 0. So local acceleration or temporal acceleration is what? It is the first term, just remind. This is the du by dt, the first term. Okay, you can see here this first term del v by del t. So it is asking in x direction. So this will be du by dt. So we can write this equation dt of u is what? Discharge per unit, q by a. So here it will comes 1 by a. It is asking about the x equal to 0. Okay, so x equal to 0 means this area becomes constant. So we can just this area will be outside. So it will be ddt of q. Okay. So at x equal to 0, what will be area? At x equal to 0, a will be what? 0.5 minus 0.2 into x. This is the equation for area. Now area is equal to what? At x equal to 0, area will be only 0.5. So it will be 1 by 0.5. Now since this it is saying that the at a given instant, at a discharge of 0.5 meter cube per second is flowing in the duct and is found to increase at a rate of 0.2 meter cube per second square. Means here it is given dq by dt, rate of change is 0.2. So will be here dq by dt is what? 0.2. So just solve this. 2 by 5 means 0.4 meter per second square is the correct answer. Option number C is the correct answer. Here just read the question. The component of velocity are given, u and v are given. What is the approximate resultant total acceleration at the point 3, 2 and time t? So here Here we need to calculate the ax and ay, okay, and that final accession will be the resultant of ax and ay. So we know this equation, these equations are already known, okay. So just we will use this equation. So here ax is what? Du by dt plus u into du by dx plus v into du by dy. This is the total accession, where this is called temporal accession or local accession, and this last two term is called convective accession. Since it is asking about the total accession, so we will find both the equation, both the accession, that is local accession as well as convective accession. So here du by dt, u is given as this t square plus 3y. So du by dt is what? 2t plus u is what? T square plus 3y into du by dx. Since u is independent of x, so derivative of du by dx is 0, plus v is given as 3t plus 3x, 3t plus 3x into du by dy. Du by dy is what? 3 only, t square becomes 0 and 3y becomes 3, okay. And for 0.32 and time t, put x equal to 3, this is x, this is y equal to 2 and t equal to t in this equation. So we will get 2 into t, 2 plus t square means 2 square, okay, this becomes 0 now, so no need to calculate this will be 0, plus 3t, 3 into 2 plus 3x, okay. So 3x means 3 into 3, 5 into 3, so it will become 2 into 2 is what? 4 plus 3 into 2 6 and 3 into 3 9, 9 out 6 15 and 15 into 3 45. So it is becomes 49, okay. So ax comes as 49. Now similarly find ay. Ay is what? dv by dt plus u into dv by dx plus v into dv by dy. Similarly for v component, v is this, so dv by dt is what? 3 plus u is what? T square plus 3y, t square plus 3y into dv by dx. dv by dx here is 3 plus v 3t plus 3x, 3t plus 3x into dv by dy. dv by dy is it is independent of y, so it will become 0. Here 3 plus t at t equal to 2, 2 square plus 3 into y is what? 2 into 3 plus 0. So it becomes what? 3 plus 2 into 2 4 plus 3 into 2 6, 6 plus 4 10 into 3 30. So it becomes 33. So this is ay. Now resultant accession is what? ar equal to root over x square plus ay square is equal to root over x is what? Here 49 square plus ay comes 33 square, and it will become finally 59.08. So the correct option will be answer 59, option number C. Here two flows are specified as A and B, two flow field are given. Now comment on E rotationality or rotationality. So which equation we will use? We will use the angular velocity, that is omega z, which is here omega z. So for A, omega z is equal to, for A field omega z is equal to half of dv by dx, here dv by dx is what? Minus 3 by 2 minus du by dy is what? Du by dy is 1. So it is not coming 0, minus 3 by 2 minus 1, minus 5 by 2, it is coming minus 5 by 4. It means it is not is 0, it means it is rotational flow. So flow A is what? Rotational. Flow A is rotational, correct? Flow A is rotational. Flow is rotational. Okay. And now check for B. For B, omega z equal to half of dv by dx. Here dv by dx is what? 2xy minus this du by dy. Du by dy is what? 2xy. So here it is coming 0. It means B is rotational flow. Means B is rotational flow. Okay. So, sorry, irrotational flow. Omega z is coming 0. So flow B is irrotational. Here A is, here it is irrotational. Sorry, this is not equal to 0. So it is rotational, and since it is coming 0, so it is irrotational flow. So we can say the flow A is rotational and flow B is irrotational. So option number C is the right answer for this question. Option number C. Here the next question, a streamline is a line. So what is the streamline? Already we know what are the definition of a streamlines. The streamlines are the imaginary lines in flow such that tangent to at any point represents the velocity vector at that point. Here you can see this is the velocity, okay, line of this V. So at any point the tangent will give you the streamline. Okay. So at streamline are the imaginary lines in flow such that tangent to at any point represents the velocity vector at that point. Okay. Suppose this is the streamline. Okay, this is the streamline. So if we take any point, at any point the tangent will give you the velocity. Okay. So we can say the streamline are the lines such that tangent to at any point represents the velocity vector at that point. So here we can see in option number D, on which tangent drawn at any point given the direction of velocity. Okay, option number D is the right answer. Here next question, a velocity field is given, u and v are given. What is the relevant equation of a streamline? Here, so just now we saw the equation of a streamline. These are the equation of streamline. dx by u is given 3xy is equal to dy by v is given 3 by 2 x square minus y square. So here 3 cancel. So we can write dx by dy is equal to 2xy by x square minus y square, which is written in option number C. So option number C is the correct answer. The next question, the differential form of continuity equation for two-dimensional flow of fluid is written as this. Okay, this is the equation of continuity, where u and v are the velocity along x and y direction and rho is the density. So since this rho is same, so we can write also this equation as del u by del x plus del v by del y. Rho is constant, so it equals 0. So we can write this is for del u by, okay, so this will be for which type of flow? This will be for, already we have read in the equation of continuity. Just see, this was the equation of continuity. So this equation is valid for steady and incompressible flow. Okay, steady and incompressible flow. Option number D is the correct answer. Okay. Here it is asking about the general form of continuity equation. So what was the general form of continuity equation? Just remind. This was the option number C is the correct answer. C. This was the equation of continuity in its most general form. So option number C is the right answer. For a steady flow, this term becomes 0, and for compressible flow, this the equation of continuity becomes this. But if it is asking about the general form, then the equation of continuity is this: del rho by del t plus del x of rho u plus del y of rho v plus del z of rho w equal to 0. Here, in a two-dimensional incompressible steady flow, the velocity component u is obtained. What is the other component v of the velocity? So, first of all, write the equation of continuity for incompressible steady flow: du by dx plus dv by dy equal to 0. So, here u is given as aex. So, derivative of aex is what? This du by dx. Okay, so these are the equation, continuity equation. So here we can write this dv by dy is what? Du by dx, correct? If we integrate this, okay, on integrating this, first of all, u is given as what? Du by dx is what here? U is aex, so du by dx is what? Aex. Okay, so we can write this dv is equal to aex into dy, correct? So here this will come this side, so it will become negative. This is negative. So on integrating this equation, of this equation, we will this v is equal to minus aex into y plus this there will be a constant, or it will be a function of x. Okay, it is a constant in terms of y function. Okay, whatever the term here will be, it is not depend on the y. Okay, it is independent of y. So it we can write as a constant or function of x, which is written here. Okay, so option number C is the correct answer. The next question: which one of the following stream function is a possible irrotational flow field? So here already we have seen in the case of a stream function. Okay, so these are the definition of a stream function. Okay, and this is the equation of rotational component omega z, angular velocity. So if we replace this v and u with psi function, we will get a Laplace function of psi. Okay, and if this becomes 0, then we can see the flow field is irrotational. So here check for a d psi by dx is what? For a d psi by dx is what? D psi by dx is 3x square y. Okay, now d square psi by dx square is equal to what? 6x y. Similarly, d psi by dy is what? X cube, and d square psi by dy square is what? 0. So here we can see this summation of this d square x plus d this summation of this term. Okay, both the term d square psi dx square plus d square psi by dy square. Okay, summation of this both the terms is coming 6xy, which is not equal to 0. So we can say this is a not irrotational flow. Okay, this is a rotational flow. Okay, so option number A is cancelled out. Similarly, check for B, d psi by dx, d psi by dx is what? Here 2y, and d square psi by dx square is what? Here 0. Similarly, d psi by dy is equal to what? Here from here this equation d psi by dy is what? 2y, 2x, and d square psi by dy square is what? 0. So here we can see the summation of these both the terms. Okay, d square psi by dx square plus d square psi by dy square equal to 0 plus 0 is equal to 0, means it is giving a irrotational flow. Irrotational flow. So here the option number B is the correct answer. Okay. For further check, you can see same process for C and D. Okay. So since here obviously the answer will be only one option, so we got the option number B is the correct answer. No need to check C and D. But for practice purpose, you can check for C and D as well. Okay. So here we can see the option number B is the correct answer. Here the next question, which one of the following stream function is a possible irrotational flow field? Similar. Okay, similarly in the previous question we have used d square psi by dx square plus d square psi by dy square equal to 0, we have to check. Now for check A, for flow field A, d psi by dx is what? Here d psi by dx is minus 2x, d square psi by dx square is what here? Minus 2. Now d psi by dy is what here? D psi by dy is what? 2y. d square psi by dy square equal to 2 plus 2. So here we can see in the option number A only, this summation of these both the terms is coming minus 2 plus 2, which is equal to 0. So we can see this is a irrotational flow. Okay, so option number A is the correct answer. Here the next question, which of the following relation must hold for irrotational two-dimensional flow in xy plane? So for checking the irrotationality in the xy plane, we use the angular velocity omega z, which is equal to half of dv by dx minus du by dy equal to 0. So for rotational flow it is 0. So we can write del v by del x minus del u by del y is equal to 0. Here you can see in the concept as well. Okay, these are the formula for omega z. So here in the option we can see del v by del x minus del u by del y equal to 0. Here you can see only in option number D. So option number D is the correct answer. The next question is the relation this del square phi by del x square plus del square phi by del y square is 0 for an irrotational flow is known as Laplace equation. Okay. So in the previous slide we have already read this Laplace equation. This is the Laplace equation for stream for velocity potential. Okay. So the Laplace equation in terms of velocity potential is this equation. Okay. So here the option number B is the correct answer. Now question number 25. Here in a two-dimensional flow, the velocity components are given x and y in terms of a stream function. Okay, so a stream function. So we need to write this stream function in terms of u and v. So by definition of a stream function, we know the d psi by dx equal to v and d psi by dy equal to minus u. Okay, what was the definition? This partial derivative with respect to any direction gives the velocity component at right angle in the anti-clockwise direction. Okay, so here we can see v is equal to d psi by dx. Okay, and u is equal to minus d psi by dy. Option number C is the correct answer. Here we can see. Here 26 number question, the velocity potential of a velocity field is given. Its stream function will be given by. Okay, so the stream function here, so this is the velocity potential and a stream function equation. Okay, so from a stream function and velocity potential we can relate this. Okay, we can write the equation in terms of psi and phi, and this both the equations are known as Cauchy-Riemann equations. Okay, so here we will use this equation. So here del phi by del x equal to del psi by del y. Okay, and minus del phi by del y is equal to del psi by del x. So here del phi by del x, this is phi, this velocity potential means this is phi is given, this is phi. So del phi by del x is what? Here del phi by del x is 2x is equal to del psi by del y, del psi by del y. Okay. Now here you can write del psi by 2x into del y. So here psi is equal to what? 2xy plus constant. Okay, this constant will be independent of this y. Okay, so here you can write this 2xy plus constant. Okay, so here you can see option number B. It is the correct answer. We can also use this equation also. From this equation you can also get this same result only. Okay, just use minus del phi by del y is what? Here minus del phi by del y is what? 2y. 2y is equal to what? Del psi by del x. So here del psi by is what? 2y into dx or del x. So psi is equal to what? 2xy plus constant. Same answer. This both the answer are same. Whether you use this equation or this equation, okay, answer will be same. 2xy plus constant. Option number B is the correct answer. The next question is, a stream function in a two-dimensional flow is given as psi is equal to xy. Now we need to tell about the potential function. So here psi is equal to xy. Okay, and we know this u is equal to what? U is equal to minus del psi by del y. So here minus del psi by del y is what? Minus x. Okay. Now another equation is what? Minus del phi by del x. Minus del phi by del x. Okay. Minus del phi by del x is what? U, which is equal to minus x. So here we can see phi is equal to what? X square by 2 plus constant. Now just del phi by del y is equal to what? This will become 0 plus this del psi 1 plus del y. Okay. Now so here this del phi by del y, we can write this del phi by del y in terms of psi. So it will be minus del psi by del y is equal to del c1 by del y. And from where I wrote this del phi by del y is equal to minus del psi by del y? From Cauchy-Riemann's equation. Here you can see. Okay, from here. So minus del psi by del y is equal to what? From here you can see minus del psi by del y is what? Minus del psi by del x. Okay, this will be x. Minus del psi by del x is what? Minus y is equal to del c1 by del y. Okay, so here we can write c1 is equal to minus y square by 2. Okay, and this put this equation here, here. So you will get phi is equal to x square by 2 minus y square by 2. Okay, this is the one process. And the another process or alternative process or shortcut process you can write, see this is the psi xy. Okay, now you can write d phi is equal to what? Del phi by del x into dx plus del phi by del y into dy from chain rule. Or here del phi by del x is what? Del phi by del x is d psi by dy. Del psi by del y into dx plus del phi by del y. So del phi by del y is, you can write minus. So it will become minus del psi by del x into dy. So here since psi equal to xy, so del psi by del y is what? X dx minus del psi by del x is what? Y. y dy. Okay, this is d phi. Okay, if you integrate this, you will get phi is equal to x square by 2 minus y square by 2. Okay, so this is the correct answer. Okay, from here you can also get the same answer. From here you can also get the same answer. Okay, so option will be x square minus y square by 2. Option number B is the correct answer. The next question is, the velocity component for a two-dimensional incompressible flow of a field is given. U and V are given. So it can be concluded that the flow does not satisfy the continuity equation, or irrotational or rotational. So we will have to check the first of all continuity equation. Okay. So what is the continuity equation for this is for incompressible flow. Okay. So incompressible flow means du by dx plus dv by dy equal to 0. Okay. Here u equal to x minus 4y. So derivative of u with respect to x will be 1 plus dv by dy. So dv by dy is equal to what? Minus 1. So it is coming 0. So we can see it is satisfying the continuity equation. It is satisfying the continuity equation. Okay. Now, so option number A is wrong because it is asking, it is saying that it is does not satisfy. So option number A is wrong. Now check for rotationality. So omega z, we will compute omega z half of dv by dx minus du by dy. So here half of dv by dx, v is what? Minus 5 minus 4x. So dv by dx is what? Minus 4 minus du by dy. Du by dy is what? Here it is minus 4. So it is coming half of minus 4 plus 4, means it is 0. It means it is irrotational flow. It is irrotational flow. It means the flow is irrotational. Option number C is the correct answer for this question. Okay. The next question is, the stream function is given, psi is given, okay, for two dimension. What is the magnitude of the velocity at point 1 and minus 1? So first of all, compute u and v. Okay, so how to compute u and v when the psi is given? By using this equation. Okay, u is equal to what? U is equal to minus del psi by del y. So u is equal to del psi by del y. So del psi by del y, from here we can see this will be minus, because this minus will become here minus 3y square, minus 3y square. So it will be 3y square. Okay, and for point minus 1, okay, this for point minus 1 it will becomes 3 into minus 1 ka square, means what? 3 only. Okay, or v is what? V is here del psi by del x, del psi by del x, 3x square, 3x square. Okay, so at point 1 we can see 3 into 1 ka square, it means 3. So it is 3j and it is 3I. So if velocity field can be written as 3I plus 3j. Okay, and the magnitude of this velocity field is root over 3 square plus 3 square, which will come at 4.24. 4.24. Okay, option number A is the correct answer. The next question, the stream function in a flow field is given by psi. In the same flow field, what is the velocity? Similarly as the previous question. Okay, in the previous question, the same process we will use here. So u is equal to what? U is equal to minus del psi by del y. Minus del psi by del y is what? Minus 2. Okay, and v is equal to what? Minus 2x. Okay, it is minus 2x, and v is what? So at point 2 it will become minus 2 into 2, that is minus 4, and v is equal to what? Del psi by del x. Del psi by del x is what? 2y. From here del psi by del y is equal to 2xy, derivative of 2xy is what? 2y. So at point 1 it will 2. So this vector velocity is given as minus 4i plus 2j, correct. So the magnitude of this velocity is what? Minus 4 square plus 2 square. So it will become 4.47 units. Okay. So option number D is the correct answer for this question. The next question, in a two-dimensional flow where u is the x component and v is the y component velocity, the equation of a streamline. Already we have know the equation of a streamline by this equation here. Okay, is v dx minus u dy equal to 0. V dx minus u dy equal to 0. Option number B is the correct answer. When we have discussed what is a stream function, a stream function is defined as its partial derivative with respect to any direction gives the velocity component at right angle in the anti-clockwise direction. Here, which one of the following equation represents the continuity equation for steady compressible fluid? Okay, for steady and compressible flow field. So we have already discussed that for steady incompressible fluid, that is option number D is the correct answer. In the continuity equation, see, this is the continuity equation. So for steady incompressible flow, okay, for steady compressible flow, okay, this is not incompressible flow, this is a compressible flow. Okay, if it will be incompressible flow, then we will use only this one. Okay, and the equation becomes this one. Okay, this is for incompressible flow, but it is asking for compressible flow, so it will the answer will be this form. Okay, in this form only. Okay, so if it is asking about the incompressible, then we will use this equation, because rho will be constant and it will become outside, and it will the equation becomes finally this form. Okay, but here it is asking about compressible flow, so we will write the answer as option number D. Which one of the following is the expression of rotational component for a two-dimensional fluid element, that is angular velocity omega z? Already we have read. Okay, omega z equal to half del v by del x minus del u by del y. Option number A is the correct answer. You can see here. Okay, the equation for angular velocity omega z. Option number A is the correct answer. Next question, which of the following relation must hold for an irrotational two-dimensional flow? Okay, so for irrotational flow, the omega z must be 0. So this omega z, the formula of omega z is this one. Okay, so it must be 0. So we can say del v by del x minus del u by del y equal to 0. So here you can see del v by del x minus del u by del y equal to 0. Option number D is the correct answer. Now the next question, question number 35. The velocity potential function is given, phi is given. So magnitude of velocity, what will be the magnitude of velocity? Okay, so the velocity u and v in terms of phi, u equal to what? Minus d phi by dx. So here minus d phi is what? This, to minus d phi of dx is what? 2x. Next v is minus d phi by dy. So minus 2y. Okay, so it will be minus 2y. Correct. U is what? Minus d phi by dx. So derivative of phi with respect to x is what? 2x. Okay, and v is what? Minus del phi by del y. So del phi of del y is what? Minus 2y. So it will become minus minus plus. Okay, plus 2y. So the velocity at point 1 1. So here at 1 it will be minus 2, and here it will be plus 2. So we can write this velocity vector as minus 2i plus 2j, and the magnitude of this velocity vector will be root over minus 2 square plus 2 square. So option number this will be 4 root 2. Sorry, 2 square. This will be 4 plus 4. So the option this 2 square plus 2 square. Okay, this will be 2 root 2. 2 root 2. okay, because this is what 4 plus 4, it means root over 8 means 2 root 2. Okay, option number C is the correct answer. Option number C is the correct answer for this question. Okay, that was all about the previous year questions asked in GATE, ES and IS from the fluid kinematics chapter. In the next lecture, we will meet with another topic of fluid mechanics. So, thank you.